we are going to talk about simplifying square roots today. Well, what's a square root? We all know what a square root is, right? So the square root of 25 is, why is it 5? Because 25 is 5 times 5, and the square root asks you what number got multiplied by itself to get the 25. The square root of 100 is 10, because the square root asks you what number got multiplied by itself. What is the pair of numbers that multiplies to get 10? And then yesterday you learned about this number. Is there any number that you can multiply by itself and get a -1? That was the question that led to the development of this special number that we call I. By definition, the number I is the square root of -1. And then if I square both sides of that, and the square root cancel each other out, I squared is equal to -1. And so that's what your lesson was about yesterday. Probably, if you're confused on that, I got something in my throat. You are trying to make it more complicated than it is. It is a definition. I is by definition the square root of -1. I squared is by definition equal to -1. And then, just like any other kind of number, you can add and subtract and multiply and divide these numbers. And they have the same rules that all of our rest of our numbers have. And these numbers can have a real number and a complex number, and just like any other number, you add like terms together. And so if you would still have some difficulty with that, I have tutoring after school today. Our lesson today is, what about this kind of number? Is there any number there you multiply it by itself that is going to equal 27? Well, 5 times 5 would equal 25, and 6 times 6 would equal 36, and so 27 is in between there somewhere. This is not going to be a whole number. This is going to be a non-terminating, non-ending decimal number. This is an irrational number. An irrational number is a non-terminating, non-repeating decimal number. But can I put it in my calculator and get a decimal answer? Well, sure I can. Here's a calculator right here. And you don't have to get your calculator out, because we won't be using calculators. And it says 5.196152423. And then it stops, because that's all the space that I have in my calculator. If I had a bigger calculator with a bigger window, it would keep going. It keeps going forever and ever and ever and ever. What we're going to learn today is called simplify square does not mean decimalize. Simplify does not mean decimalize. It is very simple to put it in a calculator and get a decimal number. But this terminology is old school. It's older than me. Back in the day, when I was in high school, I did not have a calculator. They did exist, but they were really, really expensive for just like 4-function calculators. And so high school students certainly didn't have them. And so if you don't have a calculator, it's pretty hard to find that 5.196 number. That's not simple to find if you don't have a calculator. So the terminology, what I'm going to show you, may not seem simple, but it's simpler than anything else we had back before there were calculators. Also, this will give you an exact answer. The calculator gives you a rounded off answer. Even though I have 9 decimal places, it's still rounded off. And so this simplified process is going to give me an exact answer in a form where I can tell which radicals can be added together. Now, I just used a word I'm not sure if you know. Do you know the word radical in math? Okay, you do. You just don't know it's called that. And so this symbol right here, what would you call it? Square root. The actual mathematical name for a square root, the name for the symbol itself, so I'm going to simplify the radical. Now there are several processes that you can do this, and so I started teaching it this way several years ago, and my students have been much more successful this way than any other way that I've taught, because almost everybody can divide by 2 or 3. So you're going to go over to the side of your paper, and this is going to be my little scratch part section, and I'm going to write the 27 down at the bottom. And the reason my students have been successful with this method is it starts the same way every time. Divide by 2 if you can. Can I divide 27 by 2? Then, yes, I'm talking about, when I say divide, I'm talking about divide evenly with whole numbers. So, then, if you can't divide by 2, divide by 3. 3 will go into 27 9 times. And you continue dividing by 3 as long as you can. Will 3 go into 9? And the answer will be 3. Will 3 go into 3? And when you get a 1 on top, that's finished. And this method is called the birthday cake because someone thought it kind of looked like a birthday cake. So this is called the birthday cake method. And what this birthday cake method tells me, okay, now that I have it, I'm looking for pairs. Up here I was looking for pairs, up here I was looking for pairs. I am looking for pairs. These got divided away. Do you see a pair of 3s? The pairs get to come outside of the radical sign. This symbol is just the radical sign. That's another name for square root. And what's left over? This 3 right there is left over. So this right here, this number is pairs, This number is no pairs. There's a pair of 3s, but how many 3 came on the outside? Because that's what the square root does. It changes the pairs into a single number. That was so fun, we better try again. Is that a perfect square number? No, 49 is a perfect square number, but not 48. So I go down here at the bottom of my paper, and the reason this is a good process is because you start the same way every time. If you can, divide by 2. Can I divide by 2? 2 will go into 48, and I get 24. And you keep dividing by 2 as long as you can. 2 will go into 24. 2 will go into 12. 2 will go in, I keep saying 2 and writing 3. 2 will go into 6. How many times?
3.
Will 2 go into 3?
No.
3 goes into 3 one time, and that's how you know you're done, when you get to the 1. So,
What if it doesn't divide by 2 or 3?
Get to example. You would go up in order. You would divide by 2 first. If 2 doesn't divide into it, then you would divide by 3. You don't divide by 4, because if 2 goes into it, then you've already divided by the 4s. So you would divide by 2, 3, 5, 7, your prime numbers. And so we hardly ever do one that's bigger than that. Maybe occasionally 11. So once I've divided, now what? What are the pairs? I have a pair of 2s. I have another pair of 2s. And what doesn't have a pair? And these numbers right here, I put a multiplication in. And so this is a pair of 2s times another pair of 2s. So this is a simplified number. Let's see. The next one I want to do, 180 is kind of a big number, but you will see when we start dividing by 2s, it breaks it down pretty fast. So I go over here to the bottom of my paper. Does 180 divide by 2? There are other numbers you could divide into 180, like 10 or 18, but you want to start with the smallest possible number so you don't miss a pair. You always start with 2 if you can. Will 2 go into 90? Yeah, it will. Will 2 go into 45? Now, 5 goes into 45, but you don't want to divide by 5. You want to divide by the smallest possible number so you don't miss a pair. 3 will go into 45, and so 3 will go into 45 15 times. Did I tell you the trick to tell if something is divisible by 3? 4 plus 5 is 9. 3 goes into 9, so 3 will go into 45. If you add these two numbers together and they're divisible by 3, then 3 will go into the 45. What's 1 plus 5? Will 3 go into 6? Then 3 will go into 15. Will 3 go into 5? 5 will go into 5, and you have 1 left over. So I have a pair of 2s and a pair of 3s And what do I have left over? And 2 times 3 is 6 with a 5 left over. What is the simplified, what this is called is simplifying. Simplifying does not mean decimalizing.
If it's part of decimal, it's not the answer.
That's correct. So, will 2 divide into 75? No, it's not even. 7 plus 5 is 12. 3 will go into 12, so 3 will go into 75. And so 3 will go into 7, and that would be 25 times. Will 3 go into 25?
No.
What goes into 25?
5.
5 will go into 25, and 5 left over. 5 will go into 5. Okay, now what?
5 would be the pair and 3 would be
I'm looking for the pairs. The pairs go on the outside. What is left over?
3. Will we ever have to solve that? Like,
Okay, this is called simplified. This is the simplified answer. We are going to need to be able to simplify. That's going to help us to add these together. We're most often interested in the simplified form because the simplified form is an exact answer. Occasionally, there are places where it might be more useful to have the decimalized answer, but we are going to be interested in the simplified answer. By the way, we were solving quadratic equations by factoring. Where this is leading is some quadratic equations cannot be solved by factoring. So there's a couple of skills we need before we can get the next method. We need to know about complex numbers, that was yesterday's lesson, and we need to know about simplifying today's lesson, and then we will use these skills to solve quadratic equations. Sometimes when we're solving quadratic equations, we're going to have a number that's on the outside of that radical sign. So we're going to ignore this number for a minute. We're going to come back to it, and we're just going to look at the 60. Will 2 divide into 60? Will 2 divide into 30?
no. Yes.
Yes. Will 2 divide into 15?
No.
But 3 will. 3. So, what do we have a pair of?
2.
So, we have a pair of 2s, and what's left over?
3 and a 5.
I have 2 numbers this time that are left over. Both of those numbers go inside the radical sign. Now I have to come back to this number right here. What do we have out in front?
3.
And so we still have a 3 out in front. The 3's out in front and the 2's out in front. What's 3 times 2?
6.
And what's 3 times 5?
15.
And let's see. This is like some of them maybe you looked at yesterday. There's a negative sign under the radical. So this is equal to -1 times the square root of 12.
Why wouldn't you just treat it like the positive one just with the negative?
I don't know exactly what you meant by that, but what is this? What did you learn yesterday that this is equal to? And so this is I times the square root of 12. The square root of 12 is not a perfect square number, so it can be simplified, or maybe it can be simplified. Yes, it can be simplified. Does 2 divide into 12? And 2 divides into 6? And 2 doesn't divide into 3. And what are we looking for? Now, it's just usually written this way, where that's the pair, and then the I, and then the radical. The perfect square, then the I, and then the radical. I wouldn't count it wrong if you put the I before the 2, but this is considered the usual form. And some of our problems are going to have variables in it. So what's the square root of x? Because there's a pair. What about this? 1, 2, 3, 4. That's what x to the 4th power means, right? So there's a pair and there's a pair. How many pairs do I have? Have any over? There are quadratic word problems. 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what x to the 10th power means, right? There's a pair, there's a pair, there's a pair, there's a pair, there's a pair. How many pairs? What if we have to the 3rd power? We have a square root sign. We're looking for pairs. Pairs get to come outside of the radical sign. Does this one have a pair? So he has to stay. Ones that do not have a pair have to stay under the radical sign. What if we have x to the 5th power? We are looking for pairs. How many pairs do we have? Do we have something left under the radical sign? So we -4, 18 x to the 3rd power. First of all, we have a negative in this problem. Does that mean we're going to have an I in our answer? No. I in if the if this is the negative under the radical sign. 4 is just going to be out in front. The 18 is not a perfect square number, so I need to simplify it. So, does it divide by 2? Does 9 divide by 2? And I am looking for pairs. Do I have a pair? And so the pair of 3s comes on the outside, and then I'm going to skip a space here. And what's on the inside? This 2 that's left over. And then I had my x's. And what am I looking for? How many pairs do I have? One of the pairs, that makes a pair, so that x is on the outside. Does this x have a pair? Good. You think you can do that? This is simplify. If I whole thing in there, if I put the 18 in the calculator and get that it is, do we know this symbol? You see my equal sign's crooked, wavy? That means that this is the approximate answer. This kind of answer is called simplify. When you decimalize an answer, it's called an approximate answer because your decimal has always been rounded off. It's just, have you rounded 1 or 3 decimal places? Do you think that you can simplify radicals?